Large language models are trained on a wide variety of text data to develop a broad understanding of human language. So as a result, large language models have general knowledge across numerous topics. Because of this, they suck at solving a specific task or problem you may have. But what if we can change the narrative and get this model to specialize to a particular domain or application? Guess what? That's what I'll be teaching you in this tutorial. I'll teach you how to fine-tune large language models to solve your specific task or problem at hand. I'll be sharing all the resources in this tutorial with you so that you can fine-tune your own large language model over and over and over. There is a lot to cover in this tutorial, so grab your cup of coffee and let's dive right into it. Ready to do it? Let's get right into it. So in order to make everything easy and straightforward for you guys, I've prepared this particular Colab notebook that you will just need to run, and also the most important thing is about your data. So once you have your data you want to fine-tune this model on, all you need to do is to grab this Colab notebook and follow the steps in it and fine-tune your own model. Okay, so the first thing is to connect to a new runtime. So I'll be using the GPU because Google Colab provides us with free GPU, and this will accelerate our training process. So I'll just connect to this, and it will take some time to connect to the Tesla T4 GPU, which is a free GPU provided by Google Colab for everyone to use. Okay, so I'll connect to this GPU. Okay, so you can see our runtime is connected to this particular GPU, and right after that what you need to do is to install the dependencies we'll need to fine-tune this particular model. Okay, so the model will be fine-tuning right here is the llama 3 8 billion parameters. Okay, so you need to go ahead and install all these dependencies. So we'll be cloning this particular GitHub repository, and before we even start, let me show you what is there. This particular GitHub repository helps you to fine-tune most of these open source models, so you guys can check it out. Okay, link will be in the description. You can see you can fine-tune Mistra 7 billion, llama 3, and a lot of other open source model, but I've edited this particular notebook so that everything becomes easy for you guys to use. So I'll go ahead and install all of these packages and also clone this particular repository so that we can get started. Okay, so another thing you need to know is that we'll be fine-tuning this in 4-bit. Okay, so we'll be applying 4-bit quantization, and this is because we want to reduce our memory usage. Okay, so you can do any bit, you can do 16-bit, but that's going to take a lot of memory and also take a lot of time to train. So we'll be doing this quantization in 4-bit, so you can see 4-bit is equal to true, and that's what we'll be using. So over here we have a lot of models you can use for fine-tuning your own models, and they are all listed below, but the one we'll be using in this tutorial will be the llama 8 billion parameters, and we'll be doing this in 4-bit as I said earlier. Okay, so our installation is done. We got the sources check mark. The next thing we'll do is to import this and also set these parameters. Okay, so we'll be using the llama 8 billion parameters, llama 3 8 billion parameters for this particular one. So you can see this is downloading the pre-trained model for you, and also it has listed as using our Tesla T4 GPU. It has cloned the repository. This is using the Apache license and also all other things you need for you to perform this fine-tuning process. So we've downloaded ton of files. So okay, all these files are necessary for the training process. Okay, so these files are for the llama 3 8 billion parameters model. Okay, so we are just downloading the pre-trained model so that we can use. I think it's done downloading. Now we can move on to the next step. Okay, so the next step right here is to add the LoRa adapters so that we only need to update 1 to 10% of all parameters. So we are adding the LoRa adapters. Okay, so this is straightforward. You just run this and it will just go ahead and add all of these things for you. So straightforward is done because it's something easy for it to do. It doesn't require much computational power to perform this particular task. Okay, that's out of the way, and the next step, which is the crucial step here, is about your data. Okay, the formatting which this your data need to be for you to fine tune a model with it. So we'll go through how the data should be, and for this particular one, I'm using the data from Alpaca data set, and this data can be found right here. I've also downloaded it so that I can show you the format you need to put your very own data in order to use it to fine tune a model. So when I click here, we'll just take a look at how this data looks like. So these are the string length, and this will be like the questions, and this is the input. Normally it's left out, there is nothing there, and this is the instruction. Okay, so I think looking at it here doesn't look that great, so I've downloaded this in a JSON format, and you can see how you need to prepare your data. So the data needs to be in a JSON format, and in this JSON format you can see we have instruction, and the instruction are the questions. Okay, so give 3 tips for staying healthy, and the output will be the answers. Okay, so you can provide as many answers as you want. So you can see the output, which is a long answer. You do the same thing, another instruction, you give it the output, the input is left out. Okay, so this is how you need to prepare your data. This is the formatting which your data should be before you can use it to fine-tune a llama 3 model for your special use case. Okay, so it's a lot of this data set is very big, a very big data set, of course. So this is the data set we'll be using to fine-tune our model. So I'll get back here, and you can download these data sets right from here, or even I'll just put the link in the description for you if you want to check it out. Okay, so back here, this is the data set we'll be using, and in case you have your own data set, all you need is to replace your data set with this data set in the code. Okay, over here, this is the instruction for the data set. So the data set, you have instruction, you have input and response. Okay, so for training, you need the instruction and the response so that the model will learn the pattern from your instruction and your response in order to fine tune your model for you. Okay, so all you need is to provide your data, and your data should follow this particular format. Okay, it should be a JSON format data, and inside you have your instruction and your response. The input can be left out. All right, so we'll run this cell. This will go ahead and download our data set from is a Hugging Face, and then it will split it for us to use. Okay, so that's what this line of code is doing. But if you have your own data set, you just have to load it directly. You can upload it on your Google Drive or Google Colab and load it right from here and split it. So I'll run this cell, and this will go ahead and download the data set for us. So I think it's downloading the data set and also splitting it. So it has done all those processes for you. All right, so the next step right from here is very easy, is to train your model. But before you train this model, you have to set some hyper parameters. Okay, so this is what we are doing here, and over here you can tweak these hyper parameters for your own use case. Okay, so you can see here you can make training 5 times faster for short sequences. Okay, so something we like to explore more is the maximum steps, and this is like the maximum number of epochs. Okay, so when you put it 10, then it's going to train for, let's say, 10 steps, and that's it. You also have the learning rate here, which you can tweak a little bit in order to get some good results. So for now, I'll just put these maximum steps to 10 so that it will train faster, because this is a tutorial. But in your use case, the higher you put this maximum steps, the better the model trains and understand your data for your particular use case. So you can put 1,500 and so on. It will take a lot of time to train though, but it will have influence on your output. You can also see the optimizer we are using, Adam W8bit and so on. So after everything, this will be saved in a output directory called output. So everything, including your fine-tune model, will be saved right there, and you can have access to it and use it. So these are the hyper parameters you need to set for you to train the model. I'll also go ahead and train it. But in case you also don't want to use these maximum steps, you can specify a number of epochs is equal to 1 for you to train with this, since most of you are aware or quite familiar with number of train epochs, because that's what we used to do in training deep learning models. You can substitute this, what is it, this max steps here with number of epochs. You can use both. So if you are going to go with these non-train epochs, then you have to comment the max steps out. Okay, All right, so I'll go ahead and run this cell, and this will just set these things out for us to use. Okay, so it seems that is also done. We've set up our hyperparameters, and now the next thing is to kick off our training process. That's the fun part. At least who doesn't want to see models training? Everyone wants to see AI models training live. Okay, but before we train, we can visualize some stats about our GPU and our memory usage and everything. So you can run this cell to see your GPU, the name of your GPU and your memory and everything. So the GPU you are using is a Tesla T4, and that's what is provided for you with Google Colab free of charge. So you can see the GPU right here. And then we have our max memory of 14.70748 gigabytes, and also the reserved is 5 this gigabytes. Okay, so this just prints some stats about your GPU for you. Now here comes the fun part, is to train your model. So this cell would go ahead and train your model for you, showing you the loss. So the loss will be decreasing over time as you are training the model, but in our case I'm just using 10 steps, so I don't expect the loss to decrease that much because I'm training it with only max steps of 10. Okay, and that's because it is a tutorial, which I don't want it to take a lot of time during training. It's going to prolong the tutorial, so we'll just train with max steps of 10. The training has begun, and you have your training loss and your steps. So during the first steps, this is the loss. The second step, we expect this loss to come down, but it has escalated. Okay, with the third steps, it's coming down, and so on. So it will train for only 10 steps, but in your case, for production ready models, you have to increase the number of these steps, and the higher you increase it, the better your model becomes. So you should consider doing that, but I'm just using 10 steps for tutorial 6. So we are the 6th step, and the loss has decreased to 7th step. It has also decreased to 1.1. I think that's fair enough. That's good. We started with 1.8 accelerated high, and then it's declining, becoming low. All right, so your model has finished training, and now you can go ahead and test this model. Okay, so we've trained it with only what, 10 steps, and you can see the loss has decreased over time. Now we can also show some memory and GPU stats right after the training to see our consumption. So we can run this cell, and this will show the training time, the minutes it's used to train your model, and other parameters you care of. Okay, so you guys can just see everything right here. This is not something I'm looking out for. What I'm looking out for is to run inference using this model. So the next step is to run inference, test this model, and see how it is performing right after training it. Okay, so for that, we have to load in some of this data we've used to train it to test the model. In real world scenario, you test it with different data to see how it works. Okay, so this is the format in which your data should be. You have to give it your instruction, and in this case our instruction is describe the structure of an atom, and in the data set right here, I think we have that particular question here. I'll just pick it up from here so that I can see if it can give me the same answer. So describe the structure of an atom. An atom is the basic building block of, so I'm just checking if the model I've trained on this data can provide me this exact answer. In real world scenario, you should give it something different to validate it, data it has not seen before. But let's see how it will perform. The input, I've left it blank. The only thing is what I want, the output. So once the output here is blank, the model is going to generate me the output. Okay, so the model will go ahead to generate this output for me. So we are moving everything to the GPU so that it will be fast, and this will go ahead and give us the answer we want using our model. All right, so this is done, and you can see uh the response is here. So this is the response. An atom is the smallest particle of an element that retains the property of the earth element. It is composed of a nucleus which is made up. So this is the output from our model. Okay, this is the response this model is giving us right from training it on our custom data, and I think this is fair enough. This response is very good. Proud to only training this with 10 steps. Okay, we've just trained this with 10 steps, so this result it's giving us is quite good enough and it's fair enough. If we should train more, I think this will give us much good and short answer for the question we are asking. But I think this is great, right from only training it with what 10 steps. All right, so if you want even faster inference, or you want to see everything going on in real time, you can use test streamer to run inference with this particular model, and that's what this particular block of code is doing. So it's just running inference just as we did at the top here, but this is using test streamer so that you get faster response and also see everything in real time. So I'll also run it, and in this case I'm also giving it a different instruction: give me 3 tips for staying healthy. And this is also from the data, so give 3 tips for staying healthy. I'm just copying it right from the data to test the model's knowledge about it. So I'll run this again, and in real time you can see how it will give me a very much cleaner output. So after running it, you can see the response is being generated in real time, and also this your question, your input is null, and and it's generating the response for you in real time. So this is how test streamer will help you to achieve same results. Okay, so I think the response here is also good. Eat a balanced diet, make sure to include a variety of foods, and those are the things you need to do to stay healthy, guys. um just do that and you stay healthy. So that's what our language model with fine tune is telling us. All right, now after training your model, testing this model, and you think the results are good enough for you, the next step is to save this model so that you can use it elsewhere. Okay, and that's what this line is doing. So we'll be saving this model in different formats, okay, so that we can use them in different environments. Okay, so this particular line of code only saves the LoRa adapters for you, okay, so that you can use them. But we'll also go down and save it in a format I like most, because that with that format you can run it on CPU and you will get faster inferences. So model.save pre-train, and this is the name we are giving the model. Okay, we are saving the tokenizer to, we are just giving it this name. Okay, so you can also push this model to your app. So if you are using Hugging Face transformers, you can push this model there for others to use. So if you want to do that, then you have to uncomment this and provide your Hugging Face logins, your name, and whatever you may require to put it there. But for now, I'm just saving it right in the environment where we are working. So I'll run this cell, and this will go ahead and save it. So when you click here now, you can see you have your output folder, and inside this output folder, oh no, so you have your LoRa model, and inside this LoRa model, you are going to get all your adapters saved, and you can read these adapters and use them over and over again, or you can download them and use them locally. Okay, so that's all for saving this model. Okay, so maybe after saving this model, you may want to read this model and use it again to see whether the model have saved correctly, and that's something you should consider doing. So we are reading this model and we are saying it's a LoRa model, so we are going to also test it and see whether it can answer this question: what is the famous tall tower in Paris? I'll quickly run this, and this will read the model we've saved and use it to answer the question for us. So it's like double checking whether the model you've saved is well saved and is working. So you can see it has generated a response about the tallest tower in Paris, and I think this is correct. Okay, all right, so this is the final step, and saving the model in this format. Okay, so we are saving this model in the GPT generated unified format. And let me tell you something about this format. This format allows you to run these models on CPU. So I've put in a side note you can read here. It's a method of quantization designed for large language models. It allows users to run LLMs on a CPU. Okay, so this is the greatest format I want personally. This is the format I like, so you can run it and also save it in this particular format by just clicking this cell, and it will be saved for you. If you want it in a float 16 format so that you can use VLLM for it, you can also run this cell to save it. And that's it. So you can see everything is very easy because the notebook has been well prepared for you guys to just click and run and train your own custom model or fine tune your own custom model. Okay, the only hard thing to do here is to prepare your data, because once you have your data prepared in this particular JSON format, instruction, input, output, you'll be able to fine tune your own model with this particular notebook I'll be sharing with you. The link of this notebook will be shared under the video description. You can just click on it and use it for your personal stuff. Okay, so I think this is all for this particular tutorial. If you love it, give me a thumbs up, and you can also share with people who you think they might need this the most. Okay, that's all, and I'll see you in the next tutorial.